A pot of water bubbles violently, steam rises, and the thermometer reads below 100 degrees Celsius. Nothing is wrong with the thermometer. Water does not have one universal boiling temperature. It boils when its vapor pressure becomes equal to the pressure pushing on its surface. Inside liquid water, molecules move with a range of energies. Some escape from the surface as vapor even before boiling. As temperature rises, the vapor pressure increases. Eventually, vapor bubbles can survive throughout the liquid instead of being crushed by the surrounding pressure, that is, boiling. At sea level, under a pressure of 1 standard atmosphere, pure water boils at about 100 degrees Celsius. Change the surrounding pressure, and the boiling point changes. On a high mountain, atmospheric pressure is lower. Bubbles can grow at a lower temperature, so the water boils before reaching 100 degrees. This has a practical consequence. A pot may look just as active on a mountain, but the water is cooler. Foods that depend on sustained high temperature can take longer to cook. Boiling is a phase change condition, not proof that the liquid has reached the same temperature everywhere on Earth. Increase the pressure, and the opposite happens. A pressure cooker traps much of the steam, raising the pressure above normal atmospheric pressure. The boiling point rises, often to roughly 115 to 121 degrees Celsius in common operating ranges, depending on the cooker and setting. The hotter water and steam transfer energy to food more rapidly, shortening cooking time. Once water is steadily boiling at a fixed pressure, adding heat usually makes more water change into vapor rather than raising the liquid temperature much above its boiling point. The added energy supplies latent heat for the phase change. However, real pots can show small variations because of dissolved substances, pressure changes, measurement location, superheating, and imperfect thermal equilibrium. The source's microdoctor note adds an important safety lesson. Steam can cause more severe burns than hot water at the same nominal temperature. When steam touches cooler skin, it condenses into liquid and releases latent heat. That phase change delivers extra energy before the resulting hot water cools. This is why escaping steam from a kettle or pressure cooker must be treated with particular caution. For a minor thermal burn, move away from the heat source and cool the area under cool running water. Do not use ice directly, and seek medical care for serious, extensive, deep, facial, hand, joint, electrical, or chemical burns. The science explains the added danger of steam, but it does not replace medical assessment. So water boils at 100 degrees is a useful classroom shorthand with hidden conditions. It means pure water near sea level under approximately 1 atmosphere of pressure. Boiling really occurs when vapor pressure matches external pressure. Lower the pressure, and the boiling point falls. Raise the pressure, and it rises.